Hi everyone, welcome to another lesson of IB Physics at Edu Solutions Institute. So today's lesson, we're focusing on a continuation of last week's lesson where we looked at momentum and impulse. Now, in this lesson, we're going to focus on the conservation of momentum. And what the conservation of momentum tells us is that momentum is neither destroyed, but it is conserved, meaning that the total that it was before a collision is going to be equal to the total it is after collision. So if we take two objects colliding together, then the momentum that they had before collectively will be equal to the momentum they have after collectively as well. So in this case, we see that the F net is going to be equal to 0, and that's going to be only true for the momentum to be constant. If F net is not 0, then the conservation of momentum will not stand as a true law or principle. Now we have two types of momentum collision, right? We have collision where the two objects can hit and then separate, which we call an elastic collision, or when they hit and they will actually move off together, which we will call that an inelastic collision, right? So here we have two different places. So in this question here, we have where they're going to stick together. So we have a 730 kilogram car traveling at 25 meters per second. They collide with a stationary 1,800 kilogram car and they stick together. We need to find what their velocity is after they stick together after the collision. So basically what this means, because they're moving together, we know it's an inelastic collision. And therefore, based on the diagram here at the top, we have the 730 kilograms moving at 25 meters per second. That means it's going to the right because it's a positive velocity. The 1800 before collision was stationary, so it's not moving with any velocity. Then after collision, we have to add their masses because they're moving now as a one unit object and they're moving with a velocity v. So here we go with the velocity before being 730 times 25 mass times velocity plus mass times velocity 1800 times 0, and that's going to be equal to the momentum after, which is the total mass of them together because they're moving together, multiplied by the velocity, the final velocity. When we do that, we will get that the final velocity after they collide, they will move at 7.2 meters per second. And this is an example of the momentum of inelastic collision. So in this case, we have a gun that has a mass of 975 grams. It fires a 9.15 gram bullet from its muzzle with a velocity of 300 meters per second. We're going to find the gun's recoil velocity. So what we know is that before any collision, nothing was moving, right? The gun wasn't moving, the bullet wasn't moving. So therefore, momentum before will be 0. Now, after collision, the gun will be going backwards while the bullet will be going forward. So therefore, we need to know what's the mass of the gun without the bullet, which would be the 975 minus the 9.15, which we get 9.965.85. And it's going to move with a velocity of v because that's the gun moving back with a recoil velocity. And then it's going to be minus. Now the reason why it's minus here is because the bullet is going to the left. So therefore the velocity is negative 300 multiplied by its mass of 9.15. When we do that, we get a velocity of recoil of the gun to be 2.84 meters per second. This is still an inelastic collision in a sense because before collision they were one and then after collision they separated. So it could be regarded as an inelastic or it could be regarded as an elastic collision because after collision they did separate from each other. Right? So what we notice here is that the conservation of momentum always apply to any objects that they collide with each other. And that's only true if their net force is zero. Now, if we talk about the energy that these collision or these objects have, in inelastic collision, we have the kinetic energy is conserved. And what that means is that the kinetic energy that was there before the collision is going to be equal to the kinetic energy that's there after the collision. So in elastic collisions, the kinetic energy does not change, right? But in inelastic collision, the kinetic energy is not conserved. And that means the kinetic energy it had before is going to be greater than the kinetic energy it has after they collide. And the reason for this is due to the sticking of these objects, they're going to lose motion. And remember, kinetic energy is based on motion. So because it's losing motion, then the kinetic energy is going to be less. So that means some of the energy is lost, could be due to sound, could be due to heat, and those energy forms will take away. So the kinetic energy is not the same before as it was after the collision. Right? So those are the bases on which we differentiate between the two types of collision, either being elastic or if it's being inelastic. So in a review, both momentums are conserved in elastic and inelastic, but in kinetic energy is only conserved in kinetic energy in the elastic collision and not in the inelastic collision. Right? So to find anything regards to collision, you'd have to equate the momentum before to the momentum after, right? And if the signs are different, depending on the direction that the velocities are going. So if we have something going to the right, then its velocity is positive. If it's going to the left, the velocity is negative. If it's going up, then the velocity is positive, and if it's going down, the velocity will become negative. All right, so that is our quick lesson for today. It's just to wrap up momentum and impulse. Hope you understand something new today, and I'll see you next week where we explore more on our IB physics. Thank you.